Today's notes are on linear programming. Linear programming is finding the minimum and maximum values of an objective function to a system of linear inequalities called constraints. Your feasible region is the graph of the system of constraints or inequalities. A bounded region is a closed region, such as the picture below, and an unbounded region is a region that's open on at least one side. So you can see here on the bottom on the left side, there's nothing containing it. This is an unbounded region. If an objective function has a maximum or minimum value, then it will occur at a vertex of the feasible region, so a point where two different inequalities intersect. So on your pictures above, they're located at the points that you see in either the unbounded or the bounded regions. Let's go through and look at example number 1. Example number 1 asks us to find the minimum and maximum values of the objective function subject to the given constraints. So the first thing that we need to do is take the constraints, solve them for y, and then graph them on the grid to the right. So the first one here would become y is less than or equal to negative x plus 9. The second one would become y is greater than or equal to negative 4x plus 12. And the bottom two are horizontal and vertical lines. So if I look at the first one, I'm going to start at a positive 9. And I'm going to go down 1 over 1. These lines are going to form the line on my graph. Then I'm going to look at the second equation, which has me start up at 12. It'll be up here somewhere. And it has a slope of negative 4, so I would go down 4 over 1. And I'm going to use those points. You should be using a straight edge to make sure you have straight lines when you're going in here. I also want to go back for these two lines and show where I would have shaded. So the first line was less than, so I would have been shading below. So I'm just going to draw the arrows. The second line was greater than, which means that I would have been shading above that line. I also have the line x is greater than or equal to 0, which is the vertical line here on the y-axis. And it's greater than, so I would be shading to the right. And I also have y is greater than or equal to 0, which is the horizontal line along our axes. And it was shaded above, which means that my overlapping shaded region would be this triangle right here. We now want to identify the points of intersection. So we have one here at the point 1, 8. I have one down here at the point 9, 0. And one here at the point 3, 0. These are the 3 points that contain my function. Now, in order to find the minimum and the maximum value, I'm going to take those 3 points and I'm going to plug them into the objective function for x and for y. The smallest value will be my minimum, the largest value will be my maximum. So I'm going to start with 1, 8. And I'm going to plug this into our objective function. So I have c is equal to 6 times 1 minus 2 times 8. So I get 6 minus 16, or negative 10. Next, I'm going to check the point 3, 0. The same thing, I'm going to plug it into the objective function. So I have 6 times 3 minus 2 times 0. So I get 18 minus 0, or just 18. And our last point we need to check is 9, 0. So we get 6 times 9 minus 2 times 0, which is 54 minus 0, or 54. My minimum is going to be the smallest value, so the minimum is negative 10. My maximum is the largest value after I plug it into my objective function, so it's going to be 54. So you're first going to take the constraints, you're going to graph all of them onto your graph, including the shaded region. Then you're going to identify the points that kind of contain your shaded region, and you're going to plug each of those points into the objective function. Then you're going to take the smallest value, that'll be your minimum, the largest value is your maximum. Please try and do example 2 on your own. We will talk about example 2 and example 3 tomorrow in class.